What if everything you think you know about the universe is missing a page, not a footnote, not a detail, an entire chapter, ripped out before we ever learn to read the sky? Astronomers call it the missing baryon problem. When we count every star, every galaxy, every glowing cloud of gas we can see, the numbers don't add up. Roughly half of the ordinary matter the universe should contain, the atoms that make stars, planets, and us, simply isn't where it should be. This isn't about dark matter. Dark matter was always meant to be invisible. This is stranger. This is matter we understand perfectly, made of the same protons and electrons in your body, and it has vanished from our instruments completely. For decades, this gap sat quietly in scientific papers, almost embarrassing in its size. If you added up every star in every galaxy ever photographed, you'd only find a fraction of the atoms the Big Bang should have created. The rest was simply gone. Where do you hide half of an entire universe? The first clue came from something almost too faint to notice. A shimmer, a filament, a whisper of gas stretched across unimaginable distances. Astronomers began to suspect the missing matter wasn't gone at all. It was spread so thin across the vast empty space between galaxies that no telescope on Earth could see it. Imagine trying to spot a single drop of ink diluted across an entire ocean. That is roughly the challenge scientists faced. The missing matter wasn't hiding behind anything. It was hiding in plain sight, thinned out until it became almost nothing. Then came the breakthrough. Researchers turned to an unlikely cosmic messenger, fast radio bursts, mysterious flashes of energy that crossed billions of light years in milliseconds. As their light traveled toward Earth, it passed through the near-empty space between galaxies, and something subtle happened. The signal was delayed, ever so slightly, by unseen matter along the way. Scientists realized they could use this delay like a cosmic scale. By measuring how much these radio bursts were slowed down, they could calculate how much matter the light had passed through, even matter too faint to ever be photographed directly. The result was staggering. The missing matter was there, an immense tangled web of thin gas stretching between galaxies like invisible threads holding the cosmos together. Astronomers now call it the cosmic web, and it turns out most of the universe's ordinary matter doesn't live inside galaxies at all. It lives in the vast darkness between them. This changes how we should picture the universe. We tend to imagine space as mostly empty, with galaxies as tiny islands of matter floating in a void. But the missing chapter reveals something different. Galaxies are not isolated islands. They are the brightest nodes in an enormous glowing network, a structure larger than anything the human mind naturally imagines. And here is the twist that reshapes everything. If most of the ordinary matter in the universe exists outside galaxies, then galaxies themselves are almost an afterthought, small concentrations of light within a much larger, mostly invisible architecture. The stars we see, the galaxies we photograph, the light that fills our night sky, may represent only a small, bright fraction of what the universe actually is. We spent a century mapping the universe using only the parts that shine. It's as if we tried to understand the ocean by studying only the waves that crash on the shore, never realizing the vast, dark water stretching beneath. Think about what that really means. Every star chart, every planetarium show, every image of the cosmos you've seen was built from the visible fraction alone. We were reading a book while unknowingly skipping half its pages, and the story still seemed to make sense. That should unsettle you. Our entire mental model of the universe was quietly incomplete. There is a deeper implication, too. This unseen web of gas may be the very scaffolding galaxies grew from. Long before stars ignited, filaments of ordinary matter may have already been tracing the shape that galaxies would later fill in with light. If that's true, the structure we see tonight in the night sky isn't the architecture of the universe. It's just the part of the architecture that happened to catch fire. The missing baryon problem isn't fully closed. Scientists still debate how this cosmic web formed and what it reveals about the earliest moments after the Big Bang. New radio telescopes, built to catch more of these fleeting bursts, are already refining the map. But for the first time, the missing chapter is becoming visible. So here's the question worth carrying with you. If the universe hid half of its ordinary matter from us for decades in structures larger than galaxies themselves, what else might still be sitting in the space between the things we already understand, waiting only for the right kind of light to reveal it?